All right, so this one I'm going to do by parts. And if you have a look, well, they've both got e to the x's in them, or e to the negative x. So the exponentials we like because they're easy to integrate and differentiate, but they're easy to integrate. Okay, so if I look at the first one, the integral will equal. So what I want to do is decide on which one to integrate, then leave the other. So I'm going to integrate e to the x, so that's just e to the x, and leave the other one, minus. Now I've still got that one that's been integrated, and then I'm going to differentiate the other one. So cos x goes to negative sine x, so I get negative sine x. So I've just changed that to a plus. And I'm going to do this one by parts twice, so I'm going to do it again. So I'm going to integrate e to the x, which is just e to the x, leave the second one, minus the integral of, I've integrated that one, and I'm differentiating sine x, so I get cos x, cos x dx. Now that is exactly, this part here is exactly the same as the original integral. So if I add it to the left-hand side, I've got two lots of the integrals now, being this e to the x, and I might just factorize by e to the x. So therefore, one lot of the integral will be e to the x on 2 cos x plus sine x, and it's indefinite integral, so I really should have a plus c. Okay, now in the same way, this e to the negative x, so for b, I'm going to integrate e to the negative x, so that is just happens to be negative e to the negative x, and leave sine x, minus the integral. Now I'm going to put the negative, do it again, so the negative e to the negative x is there, so this will become now positive, and sine x goes to cos x when I differentiate it. And I'm going to do the exact same thing, so I'm going to do it twice. So here I'm going to integrate e to the negative x, leave that function, and then minus the integral of, and again it's going to be negative e to the negative x, so that's going to be positive, but then I'm going to differentiate cos x, which is actually negative sine x, so I'm going to make that a negative sine x dx there. And you'll note again that this was the original integral, so I'm going to add it to the other side. Now I've got two lots of that integral, being, now these both have negative e to the negative x, and then I have sine x plus cos x if I factorize. So the integral will be negative e to the negative x on 2 of sine x plus cos x. It's indefinite integral, so I need plus c. Nice and easy.